Welcome to video 3.3, Proving Lines Are Parallel Notes. So today's objective, to use properties of parallel lines to prove lines are parallel. This is kind of the reverse of our last video, 3.2. I'll show you what I mean by that, but let's get started. Ways to prove lines are parallel. There's 4 ways. You can prove that lines are parallel if you show that your corresponding angles are congruent. You also can prove parallel lines if your alternate interior angles are congruent, or if your alternate exterior angles are congruent. And the last way to prove parallel lines if your consecutive interior angles are supplementary. Remember that from the last video. These are the angles that add up to 180. So if we can prove one of these 4 things, then we have parallel lines. Let's go to our first example. If angle 1 in the picture below is 60 degrees, what must the measure of angle 5 be so that B is parallel to K? Okay, so angle 1 is 60 degrees right here. And it's asking me what must the angle 5 be so that A and B is parallel. Well, let's look at it. Angle 1 and angle 5 are in the same position. They're both above and to the right of the transversal. So those are corresponding angles. Now, in order for me to prove that lines are parallel, my first way is corresponding angles congruent. So B will be parallel to K if those corresponding angles are congruent. Therefore, angle 5 has to equal 60 degrees. This is in the reverse order of yesterday, because yesterday we knew those corresponding angles were congruent, then we had parallel lines. Now we show they're congruent to then give us parallel lines. Let's go through another example. This will help you. Next example. If angle 3 is 65 degrees and measure of angle 7 is 3x plus 5, find the value of x that makes the lines parallel. Okay, let's first see how do these 2 lines relate. Well, angle 3 and angle 7, do you see how they're both above and to the right? So those are also corresponding angles. Now, in order to prove parallel lines, the lines will be parallel if those corresponding angles are congruent. I'm saying angle 3 has to equal angle 7. Well, I know angle 3 is 65 degrees. Angle 7 is 3x plus 5. I'm just substituting those values in. Let's solve for x. So x would equal 20. If x is 20, then those 2 lines would be parallel, and I can put in these parallel markings. Okay. Let's try these ones. So, example 3. Can the given lines be proven parallel? Explain why or why not. What we're going to do for these is first identify what type of angles we have, and if it's one of our 4 ways to prove parallel. I'll do the first one, and then you'll do the second 2. Looking at this one in the top left, I know that this angle right here is congruent to this angle right here. I don't know their measurements, but how are they related? Well, they're both outside and on opposite sides of the transversal. So these are alternate exterior angles, and I'm showed that they're congruent by the little red curves. So if alternate interior angles are congruent, am I able to prove that lines are parallel? We'll look back up on the top. Well, yes, that's option 3, showing that alternate exterior angles are congruent. So yes, line A is parallel to line B. Okay, so please do the next 2. Pause the video, identify the angles, and tell me if the lines can be proven parallel. Hopefully you had enough time. Let's look at the one on the top right. If I look at both these markings, I know that they're in the same position. They're both below and to the right. So these are corresponding angles, and they're congruent based off of the markings. Well, corresponding angles congruent, that is my first way to prove lines are parallel. So indeed, A is parallel to B. Hopefully you see your mistake on that one if you got it wrong. Next one, angle 1 and angle 2, I'm told equal 180, so they're supplementary. Let me first identify the type of angle. They're both inside and on opposite sides of the transversal. So these are alternate interior angles, and they're supplementary because it equals 180. While looking at my ways to prove lines are parallel, if I have alternate interior angles, they have to be congruent. But in this case, I have alternate interior angles that are supplementary. Now that doesn't help me. That does not allow me to prove it's parallel. So because this is the situation I have, you cannot prove that A is parallel to B. You only can prove it, and this is very important that you understand it, you only can prove that this is parallel if angle 1 was congruent to angle 2, because those are alternate interior angles. Okay, keep that in mind. Hopefully you see your mistake and we can move on from there. So, determine which lines can be proven parallel with the given information, for example 4. Okay, let's look at this closely. For the first one, you're given angle 1 is congruent to angle 5. Let's identify what type of angles I have. They're both above and to the left. So these will be corresponding angles. They are congruent. If I look back at the top of my page, corresponding angles congruent, then yes, indeed, my two lines will be parallel. When we look at this, I want to point out to you, these angles are formed by line C, D, and A. That's where angle 1 and angle 5 are created. You can ignore line B for right now. Only look at the lines that create the angle. So angle 1 is created by line A and line C. Angle 5 is created by line A and D. So that's why when I say they're parallel, I'm going to say line C is parallel to D, and A is my transversal. I'll actually put it the other way. My transversal is A. Hopefully that helps you visualize, kind of erase the ones you don't want to use. Okay, please take a moment, try the next three, identify what type of angles, and if those are able to prove parallel lines. Hopefully you gave these a shot. Let's look at the next three. So angle 1, I'm told, is congruent to angle 16. Looking at these two, what you need to notice is the lines that they're created by. If I look at angle 16, it's created by line B and D. That's what creates angle 16. If I look at angle 1, line A and line C create angle 1. They do not share the same lines or the same transversal. In this case, if I look, angle 1 and angle 16, they have no transversal, which means no parallel lines. And I'll even write a note. Angle 1 is created by lines A and C, and angle 16 is created from lines B and D. They're not the same lines, so you cannot relate them together. Hopefully you see what you did on that one. That might help you with this next problem. Angle 2 and angle 14. Let's do the same thing. Angle 2 is right here. Angle 14 is right here. Looking at the lines that create them, B and D create angle 14. Line A and C create angle 2. Again, no transversal is the same. So this one also cannot prove anything parallel because they do not share the same lines. Angle 2 is created by lines A and C. Angle 14 is created by line B and D. If you have questions on that, we can definitely go through that in class. Just look at the lines that are created. Let's do the last example. Let's check your work on that one. This should be a easier one. Looking at angle 3 and 10. Okay, what will help me is seeing they share line C. One has B and one has A. My two lines I'll be proving parallel will be A and B. My transversal is C. Looking at 3 and 10, they are both outside and opposite sides of the transversal. So these are alternate, oops, don't want to write with that. These are the alternate exterior angles, and they are congruent. That's what I'm being told. So that tells me, since they are congruent, that A is parallel to B, and my transversal is line C. Okay, I got my two now parallel lines. I'll put the markings with C as a transversal. If you have questions on that, we can definitely go over it in class, and then we will review that for you. Last property we have, the transitive property of parallel lines. Super simple. If line A is parallel to line B, and line B is parallel to line C, then hopefully you can guess, line A will be parallel to line C. I'll draw a picture and show what I mean. A and B, so this is line A, line B, if they are parallel, and line C is parallel to line B, well then all three will be parallel to each other. It's a good thing to note when we talk about parallel lines. Okay, here's the objective. Did we accomplish it? Use these properties of parallel lines to prove lines are parallel. I'm asking you, is line P parallel to line Q? Look at the 4 reasons we talked about at the beginning of the page. Identify what type of angles we have and prove, can these lines be parallel? So this would be a yes or no, and there will be some math required. Then if you flip onto the next page, I also want you to try extra example number 1. In the diagram, in the following diagrams, is it possible to prove P is parallel to Q? I want both of these completed to the best of your ability. First thing, identify what type of angles you have. 2, see if it can be proven. Can be proven parallel, and then explain. Okay, your explanations should be math equations will be your explaining. Okay, best of luck. We'll talk to you in class about this. Have a good one.